Hello guys, and welcome back to my YouTube channel. In this video we're going to be talking about how to change an alcohol to a halide. So consider this tertiary substrate where we have an OH group. The oxygen has two lone pairs that it can use to attack something that is delta plus. For example, a hydrogen attached to a halogen where the halogen is delta minus. So there is a dipole where the halogen is sucking electrons towards itself, making that hydrogen delta plus so it could be attacked by something with a lone pair. For example, this oxygen. 2 in, 2 up. And the halogen leaves and the O protonates itself. So originally it had one hydrogen. Now it is going to be attached to a second hydrogen. And the oxygen is going to be cationic. This is the best leaving group ever because it can take these two electrons and leave and become water. It will be neutral. So we get a tertiary carbocation and we get water. So now this tertiary carbocation can be attacked by something that is negatively charged. For example, the halogen, and since opposites attract, it can take one of its lone pairs and go 2 in. And what do we get? We get the chlorine now attached to the carbon that originally was attached to the OH group. So the OH changed to a halide. And this reaction would be considered SN1 because the leaving group left prior to the nucleophilic attack. Therefore, we have an SN1 reaction. Similarly, if we had this substrate, how would the reaction proceed? Well, step 1 is always the oxygen taking one of its lone pairs and attacking a delta plus hydrogen via 2 in, 2 up. So the bromine is going to leave and it is going to become anionic. And the oxygen is going to become cationic because it gained a hydrogen. Now, this is the best leaving group on the entire planet. So it is going to take the two electrons in the CO bond and go, peace out. I want to be water and I want to be neutral. So it's going to leave behind a tertiary carbocation, and it is going to become neutral, and it's going to chill. But we also have a bromine with a negative charge that was created in the first step. So this bromine, since opposites attract, is going to go 2 in and attack that tertiary carbocation, and we will get our product, where a bromine is going to be attached to the carbon that initially was attached to the OH group. So once again, an OH group was changed to a halide. So we can summarize these steps. We can say step 1 is always the oxygen is going to protonate itself. Then 2, it is going to leave as water. And then 3, a nucleophile is going to attack the carbon that initially had the OH group before it left as water. And then we will get our product. Oh no, this looks a lot more complicated. Well, it's not. Let's do this example. So, step 1, the oxygen is going to protonate itself. So it's going to attack that hydrogen that has a delta plus because it is attached to a delta minus halogen. 2 in, 2 up. The halogen is going to leave and it is going to become anionic. So later it is going to be our nucleophile. Because the oxygen grabbed a proton, it is going to lose an electron to that hydrogen that it grabbed and become cationic. And we know when we get OH2+, that we have the best leaving group ever. Yay! Yay! So what's going to happen is it's going to leave. Leaving groups like to leave, especially OH2+. Peace out. Well, then we get a tertiary carbocation. And this carbocation is going to be trigonoplanar. Its hybridization is sp2, trigonal planar. Therefore, our nucleophile, which is going to be our halogen, that gained that negative charge in the first step, can attack from the top or the bottom. Therefore, we're going to get a racemic mix. So it could go from the top to in, or it could go from the bottom to in. There's no to out because the leaving group already left. So for our final product, all we have to do is draw the iodine on a wedge and also on a dash. So iodine on a wedge in one of the products, and the iodine on a dash. And there you have it. There's 3 examples of a tertiary alcohol changing to a halide group via an SN1 reaction. Alright guys, I hope this video was helpful. Please make sure to leave a like, comment, save, and or subscribe to my channel. And leave a comment down in the comment box below if you have any suggestions about topics that you would love for me to cover next, because this is all about you and your learning experience. So let me know what you want and I will provide it to you. Alright guys, peace out.